All right, so if we have the, like we looked at already, 0, 0, infinity over infinity, we could do L'Hopital's rule. Now we skipped over this one yesterday, but I think there was one in the homework like this. You may have to do L'Hopital's rule more than once, right? So you may have to do L'Hopital's rule and you still have 0 over 0. So you can do it again. So the ones today are going to be not 0 over 0 or infinity over infinity. They're going to be something else. There are other indeterminate forms. Where are they at here? I'm going the wrong way. Something like 0 times infinity, 0 to the 0, 1 to the infinity. And what the first thing we're going to have to do is we're going to have to transform these into 0 over 0 or infinity over infinity. So let me show you what I mean. Let's look at the first one here. So let's say we have the limit as x of natural log as x approaches 0 from the right. Now, as we substitute in 0, this is going to be 0 times, and if you remember natural log, we would graph natural log. Natural log looks like that. So as you approach 0 from the right, natural log goes to negative infinity. So this limit is 0 times infinity. So we can't do L'Hopital's rule. But we know if you take 1 over 0 in a limit, right? That goes to infinity. And we know 1 over infinity goes to 0. So we can use that. So I'm going to write, to kind of show you what I mean by that, I'm going to write two things down, and then we're going to decide which one we like better, and then we'll go back and just deal with that one first. So don't write anything down here yet. And then once we decide what we want to use, I'll show you. So what I can do is I can rewrite this like this. I can rewrite this as the natural log of x divided by 1 over x. Notice the x here, I can just write it as 1 over x. That's kind of, if we look at 1 over x, that equals x. We kind of talked about that yesterday. Okay. So I could do that, or I could do this. So what I've done is I have taken the top, I've taken one of these and moved them to the bottom. Now, as x goes to 0, this is infinity on the top, and 1 over 0 is infinity on the bottom. Here, as it goes to 0, I have 0 on the top, and then I have 1 over infinity here, which is 0. So both of these are in the form of 0 over 0 and infinity over infinity. So I now can do L'Hopital's rule. But here's the question. If you're going to take the derivative, which looks easier to take the derivative of? The top one or the bottom one? The top. The big thing on the bottom is we got to deal with 1 over natural log, right? We don't want to do that, right? That's not something we want to tackle. So instead, what we're going to do here is we're going to get rid of this. And we are going to rewrite this as natural log of x divided by 1 over x. So what I have done is I have taken this x here and I have moved it to the bottom like that. So that I now have 0 over 0 or infinity over infinity. Now we're ready to do L'Hopital's rule. So I had to do one step to get it in the right form. Now, this is why we write the little LH when we do L'Hopital's rule, because we just did the first step and we didn't do L'Hopital's rule. We just did some algebra, right? Now, when we do L'Hopital's rule, we write LH to say, hey, we're doing L'Hopital's rule, we're taking derivatives. The derivative of natural log is 1 over x. And then how would you take the derivative of 1 over x? And don't say quotient rule.
Like x to the...
Right. I would treat this as, think of this, I would think of it as x to the negative 1. And then I can bring down the 1 and subtract 1. Like that. So now, I can simplify this. I have 1 over x times, this is just negative 1, and x to the negative 2 is really just negative x squared up on top. So notice, this is why we put the LH there. I haven't done L'Hopital's rule, right? I'm just doing some algebra. And then this is going to give me the limit as x goes to infinity of negative x. I have an x squared on the top and an x on the bottom, which simplifies to negative x. So that is just 0. Okay. All right, let's try another one. Let's say we have x to the x. Okay. This is the indeterminate form of 0 to the 0. So if we plug in 0 here, we get 0 to the 0. We have to figure out how to do that. Now, there's going to be a trick, okay? We had this rule with e to the natural log. It tells, this is how, if you go back, this is how we found the derivative for exponentials and natural log with this technique. So if we have e to the natural log of x, that is just equal to x. Or if I have something x cubed, that is equal to e to the natural log of x cubed. That's just a rule of exponents and logarithms and exponentials, okay? Now, why would we do that? Okay? So what we can do is we can take this limit and I'm going to rewrite this as e to the natural log of x to the x. Now, why would you ever want to do that? We just seem like we've made this so much harder than it was a second ago. The reason is, just like up here, the reason we did this when we did it before, is because it's a logarithm, you could take this 3 and move it out in front. So x cubed, I could rewrite it as e to the 3 times the natural log of x. And the advantage is if you have e to some stuff, what's the derivative? The derivative of e to the stuff is e to the stuff times the derivative of the stuff. So e just makes it easier, okay? So here we can do this e to the natural log. This allows us to move this in front. And we get ex to the natural log. So what we have done is we've gotten rid of x to the x, and we've changed it to just x times natural log. So we made it a little bit different, and we have the e there. Now, e is just a number, isn't it? So that doesn't change. So this right here basically is going to be e to whatever the limit of that exponent is. So really what we have to consider is, what is the limit as x goes to 0 of x natural log of x? Because whatever that is just our exponent right there. Does that make sense? it'd be similar if we had this. If I said, what's the limit of x to the 1 of 2x squared minus 3? Well, really the only part that has a variable is the exponent, right? So my answer is just going to be 2. Really all I got to do is figure out what's the limit of the exponent. And then that just goes there. Does that kind of make sense? So that's what we can do here. Now, do we know what that is? What is it? 0. How do we know that's 0? That was the last one we just did. Okay. So this gives us 0. E to the 0 is equal to 1. So the limit of x to the x as x approaches 0 from the right is equal to 1. All right, let's try another one where we got to do this like e to the natural log or something, okay? Let's see, where do I want to... All right, so let's skip that one for going right down to the... Too much written down there. So we have the limit x to infinity of 1 plus 1 over x to the x. Right? All right, let's do this one. So anytime we have this kind of x to the x, we need to do the e thing. So we need to e it, which is e to the natural log of 1 plus 1 over x to the x, which is e x natural log of 1 plus 1. So we kind of do this, the exact same thing. We're going to do this e to the natural log. Anytime you have variables raised to a variable, this is what you convert it into this e natural log thing to make our life easier. As we do it, okay? Now, as before, now really what we can do is we now can just look at this limit. Because whatever that limit is going to be our exponent here. So it's going to be e to whatever that power is. So let's consider this limit. As x goes to infinity, x is infinity, the natural log 1 over x, as x goes to infinity, it goes to 0. So this just becomes the natural log of 1. The natural log of 1 is 0. So we kind of have an infinity times 0. So once again, we got to do something to put this in the form that we can solve it. So I'm going to say this goes to infinity. I'm going to get the natural log of 1 plus 1 over x all over 1 over x. Got to do the same thing. I got to take this to the bottom. So I now have 0 over 0. Now, we're ready to do L'Hopital's rule. So first, you try to take the derivative. Take the derivative of the top and of the bottom. Did you get to there? The derivative of natural log is 1 over, so it's just 1 over the same thing, times the derivative of the inside piece. But the derivative of the inside piece is just 1 over x, which is the same thing we got on the bottom, 1 over x. So we get to here, these two things cancel. So we basically now just have the limit as x goes to infinity of 1 over x. As x goes to infinity, this right here goes to 0. 1 over infinity goes to 0. And we get just 1. Now, we got to go back up. And this right here, then, we just found this limit as 1. This is e to the 1, which is just e. So our limit is e. Now, I don't know if you remember this or not. Like the second day of class, we looked at this limit. And I said, this is the definition of e. We didn't know how. We looked at it on our calculator, just guessing and checking large values for x to show that it worked. But if here is the proof that this is e. One of the things you've got to be careful of that's hard with these, and this is very fresh in my mind because of a situation I had with my own son. He had a problem like this on his calc exam, and he was complaining, this was years ago now, he's a senior now, because he did all of this and got an answer of 1. But forgot to go back up and put it right there in the exponent to get e, and he missed, like he said, he got like half credit. So he this was, and it wasn't this exact problem, but this idea. So he got to here, did all of this, wrote it in terms of e, did all of this on the test, did all the limits and derivatives and simplifying right, and got to the right answer here of 1. But forgot to go back in and plug it in to get e. So just be careful on these. That's what I said. That's just not a huge thing. I don't think I would take half off if you did that in my class. I'd be like, you did all the hard part right, but that's what happened. Okay. All right. So we looked at 3 of these. Our indeterminate forms. We looked at 0 times infinity. This one ended up being 0. We looked at 0 to the 0. When we did that, this ended up being 1. And then this last one, 1 to the infinity, this one ended up being e. Okay? So we're going to try one here. It's not on your notes. So we're gonna skip the one. Flip it over to the back of your notes. We're going to skip the one that is this one here. I'm not going to do that one. Let's do this x to the 1 over x. So we'll just try this. And it's not even up here, is it? Okay. So go to the back. And we're going to try that one. So x to the 1 over x. So let's try that one. So let's try the limit as x goes to infinity of x to the 1 over x. So on the back, we're going to skip the other one. Let's try this one. Okay. So from what we've just been doing, think about what you would do. Okay. How you would solve that. So once we get to there, now we can say, okay, all we need to worry about is the exponent. When we get to there. So, what form do we have? What happens if you plug in infinity right now? 1 over x goes to 0, right? And the natural log of infinity goes to infinity. So as this is right now, 1 over x is 0, and natural log is infinity. Okay. What if I just did this? Is that the same thing? Just combined it. If I'm multiplying, I combined it into a single fraction. And now when you put infinity in, you get infinity over infinity. So now, do L'Hopital's rule. See if you can finish it. Did you get to there? Let me take through this. Now this is really, dividing by 1 doesn't matter. So that's just 0. Now we got to come back up here, and we just get e to the 0. You get a lot of zeros and ones doing these problems, because you got the e's and the natural logs. Okay. All right. I'm going to give you 2 more problems for homework. So, as you look at this homework, cross off number 1. Don't do number 1. Flip it over to the back. Cross off number 4. Okay. The 2 I want you to do are 2 and 3. Now, if you look at 2, 2 is, if you want to write this down, it is infinity times 0. The sign is pi over infinity, which is 0. So it's sine of 0, which is 0. So this is 0 times infinity. So you're going to have to rewrite it to get 0 over 0 or infinity over infinity, right? Flip it over to the back. Number 3, you have x to the square root of x. That one, you're going to have to write it as e to the natural log, right? So the one on the front, is kind of like this. You just have to rewrite it and then solve it to get it in the right form. The one on the back is more like this, where you're going to have to, you have x to an x, you're going to have to write it as e to the natural log. So homework-wise, you got to do 1 of each, okay? In addition to the first worksheet from that we already had the other day, okay? So we have 2 for L'Hopital's rule. We have part 1 and part 2, and then the related rates in delta math.